Welcome. Let's discuss how we can solve absolute value inequalities. In our first example, we want to see when is the absolute value of x plus 2 less than positive 6. The first thing that we want to do, we want to rewrite the problem, and instead of working with an inequality, we're going to work with an equation. So now we're going to get the absolute value of x plus 2 equals to positive 6. And now that we have changed the inequality with an equation, now let's solve this absolute value equation. And remember that to solve for an equation, we're going to take what is inside the absolute value, and we're going to set it equivalent to the positive and the negative of what we want the equation to be equivalent to, which is in this case 6. So we got two small equations, x plus 2 equivalent to positive 6, and x plus 2 equivalent to negative 6. And now we can solve each one of them independently. The equation on the left, let's subtract 2 to leave the x by itself. So now we have our first solution, x is equivalent to 4. And in the second equation, let's subtract 2 as well. But now we're going to get that x is equivalent to negative 8. Now these are not the solutions of the inequality, but we will use these values to solve the inequality. Because now, in our second step, let's place these values in a number line and create intervals. So let's draw a number line. Let's say that in the middle we have 0. So negative 8, it should be somewhere over here. And positive 4, it should be somewhere over here. And notice that when we place these two values in the number line, then the number line gets cut into 3 different intervals. The interval from negative 8 to negative infinity, the interval from negative 8 to positive 4, and the interval from 4 to positive infinity. So the interval from negative infinity to negative 8, let me call it interval 1. The interval from negative 8 to positive 4, let me call that interval 2. And the interval from 4 to positive infinity, let me call that interval 3. Let's move the number line more to the center. Because now what we want to do, we want to test each of those intervals. Let's choose a number in our first interval, from negative 8 to negative infinity. I'm going to choose the number of negative 10. And the way that we're going to test our interval is we're going to get this number in our interval, and we're going to plug it in to the inequality that we wanted to solve. And now we evaluate. Inside the absolute value, we're going to get negative 8. And the absolute value of negative 8, it is positive 8. So notice that this expression that we got here, it is not true. It is not true that 8 is less than 6. So we know that the first interval, we will not take it in consideration as part of our solution. Now let's test our second interval. Let's choose a number between negative 8 and positive 4. I'm going to choose 0. Let's get that value and plug it into the inequality that we started with. And now let's evaluate. Inside the absolute value, we're going to get 2. And the absolute value of 2, it is 2. And notice that the statement that we got, that 2 is less than 6, it's definitely a true statement. So we will consider this interval as part of our solution. Now let's test the third interval. Let's choose a number that is greater than 4. I'm going to choose 5. Now let's plug that value in our inequality. And let's see if we end up with the true statement. Inside the absolute value, we're going to get 7. And the absolute value of 7, it is positive 7. Now notice that the statement that we got, it's definitely false. 7 is not less than 6. But the only interval that we found to be true, it is the second interval. Therefore, the solution for this inequality is the interval from negative 8 to positive 4. So let's visualize what we have said here. In our graph, here in red, we got the graph of the absolute value of x plus 2. And in green, we have the line y equals 6. So if we want to visually find the solution for the inequality that we are given, we're going to be looking at those y values in the absolute value that are less than 6. And notice that those y values are highlighted here in blue. And notice that the interval where this occurs, is at the interval when x is equivalent to -8 and when x is equivalent to +4, which is exactly what we found here algebraically. Let's take a look at another example. Now let's consider the inequality 1 plus the absolute value of 1 plus x being less than 4. We're going to approach it the same way as we did before. The first thing that we want to do, let's rewrite this as an equation. And then let's solve this equation. Let's start by isolating the absolute value. So let's subtract 1 to both sides. And now to solve this equation, we have to consider two cases where the inside of the absolute value is equivalent to +3 and the inside of the absolute value is equivalent to -3. And now we solve each equation. On the equation on the left, let's subtract 1 to both sides. So here we have our first solution, x is equivalent to 2. And the equation on the right, let's take away 1 from both sides. And we got our second solution, x is equivalent to -4. But these are not the solutions of the inequality. These are the values that we will use to create the intervals for the solution of the inequality. So now let's create our intervals. Let's draw our number line. Let's say that 0 is here in the middle. And now let's place our values, +2, somewhere around here, and -4, somewhere around here. So notice that the number line was cut into 3 intervals. The interval from -infinity to -4, the interval from -4 to +2, and the interval from 2 to +infinity. Let's label those intervals. The interval on the left, let's call it 1. The one in the middle, let's call it 2. And the one on the right, let's call that 3. Now let's test each of those intervals. Let's choose a number in the first interval. Any number that is less than -4. I'm going to choose -5. And now let's plug that value inside the inequality that we started with. Inside the absolute value, we're going to get -4. The absolute value of -4 is 4 plus 1. We're going to have 5 on the left. And now let's see. Is 5 less than 4? Definitely not. So we know that this interval is not part of our solution. Now let's test our second interval. Let's choose a number between -4 and 2. Always choose an easy number. I'm going to choose 0. So let's plug that number in the original inequality. Inside the absolute value, we're going to get 1. The absolute value is 1 plus 1, then we're going to get 2 on the left. And notice that this statement, it is true. 2 is definitely less than 4. So we know that the second interval is going to be part of our solution. So let's highlight it in blue. Now let's test a value in our third interval. I'm going to choose the number of +3. Now let's plug that number in the inequality that we wanted to solve. Now let's evaluate. Inside the absolute value, we're going to get 4. The absolute value of 4 is 4 plus 1. We're going to get 5 on the left. And now let's look at the result. Is 5 less than 4? Definitely not. So we know that the third interval is not going to be part of our solution. The only interval that was true is the second interval. Therefore, our solution is just the second interval. Now let's visualize our result. In this graph, the red lines, they represent the equation of 1 plus the absolute value of 1 plus x. And this green dotted line represents the line of y equals 4, which is the right-hand side of the inequality. So if we wanted to find the solution for when 1 plus the absolute value of 1 plus x is less than 4, we want to see when is the equation of the absolute value is below the line y equals 4. And notice that that is happening here in blue. But what are the x values that we have in this interval? On the left, we have x is equivalent to -4. And on the right, we have x is equivalent to 2. And notice that that is a solution that we found algebraically. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.